students, welcome to the online session or the subject of structural analysis. This subject of structural analysis is mainly for the student of structural engineering. Basically, in design of any kind of a structure, first of all, analysis is required to be done. If the analysis of the structure is done properly, then the design of the structure can be done properly. So basically, we can say that structural analysis is very important subject for the structural engineering students. So let's start with this important subject of structural analysis. So 3, 2, 1. Let's start. Welcome back students to our online session. In previous session, we have discussed the stiffness factors and the distribution factors. Okay, we have discussed all the thing that is required for our calculation of the distribution table, this moment distribution table. Okay, we have founded the fixed end moment in the previous session. We have found the stiffness factors which were further helpful in the distribution factors. Okay, so yes, that all the thing which we have done in the previous session, in the just previous session, will be using it in this session for the calculation, and here we will be preparing the moment distribution table. You can see over here. So in the moment distribution table, the first row will be of the joints. Okay, so from the figure we can see that there are only 3 joints, that is A, B and C. You can see over here we have only the A, B and C. Okay. The B, you can see over here that it is being located eccentrically. So we have to consider that also for our calculation. Now you are seeing this figure, and the next step in the moment distribution table will be of the members. So here the members will be AB, then BC and BA will be related to the joint B. So it will come under the category of joint B, and then we will be having the CB member which is having the joint C. So let's see that in our distribution table, the moment distribution table. Okay. So yes, I need to reach to that. Okay, now it's done. You can see. So you can see that the first is the joint. The joint is only A, B and C. After that, we will be having the members. The members in joint A will be only AB. Now in joint B, we will be having the member AB, BA also and BC also. So that also you have to consider. After that, we have the joint C. The member that is related to joint C is only CB. In the next row, we will be having the distribution factor. So distribution factor is being calculated previously. Yes, this is the distribution factor. These are the stiffness factor and this is the distribution factor. Okay, we have calculated. So just we have to keep it in that table. In this table, you have to keep that. So for AB member, we have the distribution factor 0. Then in BC, particular joint B, in BA member, we are having the distribution factor as 0.33. After that, we will be having the BC member, and there we are having the distribution factor as 0.67. Again, moving towards the joint C, there we are only having the member CB. So there you can see the distribution factor is C. Okay. So yes, you have to keep over here. After that, you have to place all the values of the fixed end moment. So fixed end moment we have calculated previously for AB, for BA member, for BC member and for CB member also. So all the 4 members friction moment we have already calculated. It's now the time to keep that values. So seeing over here, the AB member is having the friction moment value of minus 12 kilonewton meter. Then BA member will be having the positive value and it will be 12 kilonewton meter. Moving towards the next member, that is BC member. So there we are having the value of minus 42 kilonewton meter, and after that we are having the member of CB. So there we are having the positive 48 kilonewton meter. Okay. So now it's time to have the distribution method. So we have to distribute this. So while distributing it, means we can say that while making the calculation, that is plus 12 minus 48. So we will be getting minus 36. So that we have to multiply with the distribution factor. Okay, we are now at joint B only, because B is only the joint which is to which the members are being connected. At joint A and at joint C, there is only one member, there is no other member. So there the carryover process will not going to take place. The carryover distribution will be only going to take place at B joint. So the members that are related to B are only the BA and BC. So we have to take the addition of the moments of that joint only. So there the members are BA and BC. So we have to add so whatever the moments that we are getting. So BA we are having the positive 12 kilonewton meter and BC we are having the minus 42 kilonewton meter. So we have to add them. So ultimately we are getting the value of minus 36 kilonewton meter. So that is the moment that we are getting at joint, because we have to add it, and whatever the sign in the preceding of that value will be, that will be considered, and accordingly the thing will be happen. So if it is negative, then subtraction will be also going to take place, and if both are positive, if both were positive, then we will be doing the addition. But at present you can see that there is a negative value in the member BC. Okay. So yes, while calculating, we are getting the difference of minus 36 kilonewton meter. Okay. So that is the net moment at the joint B. So that is the moment that we have to distribute. So we have to multiply it with the distribution factor. So for BA, we have to multiply minus 36 with 0.33. So minus 36 into 0.33, we are getting the value of minus 24.12 kilonewton meter. But when we are distributing it, we are doing the balancing. At that time, we have to take the opposite side, because we are just balancing it. So we have to take the opposite side. So we are getting minus 24.12 kilonewton meter. We will be taking as plus positive 24.2 kilonewton meter for the distribution at BA member. Okay. Now moving towards the BC member. So again at the joint we have found the difference of minus 36 kilonewton meter. So we have to multiply it with the distribution factor of BC. So that is 0.67. So minus 36 into 0.67, we are getting the value of this one 11.188. So that we have to consider. Okay, and yes, we have to take it. Now next step is the carryover. So 24.12, whatever we are getting, we have to carry over it for the adjacent member. So for BA, the adjacent member will be AB, and for BC, the adjacent member will be CP. So half of it we need to carry over. Okay. So yes, so while carry over it 24.12, its half will be carry over. So it will be plus 12.06 moment at AB, and while carry overing 11.88, its half will be carryover and it will be 5.94, that is the carryover moment at CV. Okay. So in this particularly this sum we are having only one joint. So further no carryover or distribution process will be going to take place. This is uh, the step. This is the only step that can be done the moment distribution method table. Only the distribution of the single step only we have to do. Okay, on single step only the distribution will be going to take place. So now it's over. Now we have to calculate all the moments, that is from friction moment to balancing and to carryover. All the moments that we are getting, we have to we can say that we have to calculate it. We have to do the addition of all the members. And if we are finding the negative, that subtraction will be also going to take place. So by doing so, in this you can see that at joint A for AB member, the initially it was 12 and below we have got, initially it was minus 12 and below we have got the positive 12.06. So finally we are getting the final moment of 0.06 kilonewton meter for AB member. After that it's time for BC. Sorry, after that it is time for a joint B and particularly for BA. So while calculating all the moments from the initial moment to the carryover and the distribution, finally we are getting the moment of 36.12 kilonewton meter. After that it's time for BC. So for BC we have to calculate and finally we are getting minus 36.12 kilonewton. Okay. And particularly at joint B, for BA we are getting the 36.12 kilonewton meter and for BC we are getting minus 36.12 kilometer. Means at joint on both the side, on the left side and the right side, we are getting the same value but the sign is different, and that is the signal that makes us see that our calculation is proper, because everything is being nullifying. Okay. Both the members, its moments are compensating each other. So we can say that our joint will be in an equilibrium. So if you are getting both the values same at a joint, the difference will be of just sign only. Or one will be positive and other will be negative. And if this thing happens in your calculation, this means that your calculation is correct. Okay. So there is no need to again do the moment calculation and perform the carryover steps and distribution steps. Okay. Then finally we are at the C joint. So we have to add all the moments and finally we are getting positive 53.94 kilonewton. Okay. So as our members is fixed at A and C, means at both the supports it is fixed. So definitely there will be some bending moment. Okay. So now this is what we are getting the final bending moment. Now it's time to prepare the shear force and bending moment diagram. So this is how the figure will be. Okay. You can see over here given below C diagram. It is nothing but a shear force diagram, that we have to take the loading and we have to take the supports. We have to find the supports and based on that we will be getting the bending moment diagram. So ultimately the supports, the reaction at A we are getting is 24.75 kilonewton, and from moving towards A to B it will be, we are finding that there is a UDL, that is having the load in downward direction. So finally at joint B we will be having the 32.25 kilonewton. Okay. And again there will be the reaction at B. So there will be an increment in the value and we will be getting 52.25 kilonewton, and for span BC we have considered as an equivalent load at center, and yes, because of this we are again moving downwards and finally we are getting the 42.75 kilonewton reaction at C. Okay. So this is the, now in bending moment diagram also it will be like this only. You can see that it is a parabolic, and below at the bottom you will be having the value of 15.75 kilonewton meter, and at the top somewhere at a point in the BC span, you will be getting a 7.13 kilonewton meter. Okay, so this is how the bending moment has been taken place. Okay, so here we are completing the chapter of the moment distribution method. You have to prepare the bending moment and the shear force diagram. You have to take all the bending moments that you are getting in the bending moment table, and you also have to find the central bending moment. Okay, that also you have to consider it. So both of them is equal to be taken in the bending moment diagram. Okay. And again the shear force also you have to prepare, and this moment that you are getting is bending moment distribution method is very much precise, and it is very much helpful in finalizing the moment that are going to take place in the structure, and based on that we can provide the reinforcement. So this is how this method is helpful to us. So thank you for attending the session. See you in the next session. So here we are ending our session. Hope you have liked the session. We have discussed each and every topic in brief and also in detail. We have discussed each and every topic's practical application also. So thank you for attending the session. And if you have any kind of a doubt, if you have any kind of a query, then you can send me your doubts and queries in mail. My mail is in my YouTube channel. Do check into my YouTube channel, like it, share it, and again thank you for attending this session. See you in the next session. Thank you.